All right, I'm back with lesson 5, your favorite Walmart version of Khan Academy. Anyway, so for our warm-up, something to notice about these graphs versus their equations is if you look at the x-intercepts, you'll see that they are like opposite numbers of what's going on in the parentheses. So like this x plus 5 factor actually caused this x-intercept at -5. The x plus 1 caused one at -1. X minus 3 caused one at +3. And that's true for all of these. Okay, so it's really important to note that the x-intercepts come from numbers that will cause these factors to equal 0. If I plugged in a -5 here, right, -5 plus 5, that equals 0. And that is how you find x-intercepts. Okay, is whatever numbers make these factors equal to 0. For the sake of the fact that I have a time limit on how long this video can be, I'm going to move on, but make sure you write whatever you need to on your page. So we are going to do these problems where we want to find all the values that would make these equations true. And if you notice, they're all equal to 0. So we're just trying to find all the x values that make our equation 0 if we were to plug it in. So by zero product property, as long as we make any one of these parentheses equal to 0, it'll do the trick. So here, for this one, if you plugged in a -4 for x, -4 plus 4, that would equal 0, right? Like if I could even set up an equation and solve it, you would say, oh, x equals -4, great. So we got -4, this one is going to be -2, and this one's going to be +1. It's really easy when it's just like this and simple because you just take the opposite sign of all the numbers. So this one, -4, -2, 1, 3. We're still just taking all the opposite signs because since it's such a basic equation, these are easily the numbers that would zero out all of these parentheses. So, 3 minus 3 would get us 0. 1 minus 1 would get us 0. -2 plus 2 would get us 0, and same with the -4. For this one, same idea. These squares don't make any difference because 0 squared is still 0. So -4, oops, and -2. Moving on. This -2 out here actually won't make any difference to us at all because there's no x's involved. We're going to do the exact same thing. So 4, 2, -1, -3. If you hear the music playing in the background, that was my phone ringing, which I'm ignoring because clearly I'm occupied. Okay. And for this one, it's the same idea, but just a little more complicated. So you still want to figure out what makes these all equal to 0, but you actually have to do a little extra work. And that's kind of like how we did this one, except this one was super easy, so you barely even noticed it. For this one, we would let's go ahead and actually take 2x plus 8 and set it equal to 0 and solve it. So you subtract 8 from both sides. You get 2x equals -8. So now, to get x alone, we need to divide by 2, since it's being multiplied here. That goes away, x equals -4. I'm just making that 8 worse. Oh my god, that's horrible. That's an 8, guys. So x equals -4. Since I'm in a rush, I'm not even going to bother with it. You're going to do the same thing for each of these. Set them equal to 0 and solve them just like we did here. And you should get +3/7 and then 10. This one's easy. Make sure in your books, be honest, this is only gonna, be for you in the long run. Actually make sure you know how to solve these and get all of these answers. We're gonna skip number 6 for right now. Number 7, same exact idea. What could I plug in for x here to make this parenthesis 0? Well, 3 minus 3 would give me 0, so that's a solution. 1 would give me 0 there, and then here just a -0.75, so nothing too crazy. However, there is an x out here, and this is kind of as if we had something like this, right? It could be written as x minus 0 too for all we care, but you can also just write it as a plain old x. And in order to make that 0, it's just 0, right? It's so simple that you might overlook it or not realize how simple it is. So those are my solutions there. And for these two, this one actually is a little different. This square actually does matter, so we're going to go ahead and do it the old-fashioned way where we set up an equation and solve. The -9 we can actually just write, though. That one's easy peasy. And then, so, all right, let's solve this equation. We add 4 to both sides, and we get x squared equals 4. Now, hopefully you guys remember from algebra that if you want to get x alone when it's being squared, you need to square root both sides. You might say the answer is 2, but actually when you square root a number, you can have a positive and a negative answer. Because if you were to work backwards and say, oh, well, what number squared gets me 4? 2 and -2 both work, right? Because when you square a negative number, it still ends up positive. So 2 and -2 are both answers here. So what we just did was we found all the x-intercepts of all of these graphs. For number 6, this is really doing a throwback to algebra, and you have to factor it. This is in standard form, whereas all the other ones, which we liked, are in factored form. So I'll do a really quick little crash course on factoring here. We're going to put our work for number 6 down here. X squared plus 3x minus 4. So we're going to do like the box and diamond method. So when you're setting up factoring, you make your little 2x2 box and your x. This is super ugly, but it's fine. The setup is always the same. The first term goes in the first box here. The third term goes in the last box at the bottom right. And then in your diamond, you're going to put the middle term on the bottom. That's what we need to add up to make. Oh, that's why I'll put a little plus sign down there. And then on the top, you have to multiply these two. Okay, that was pathetic. Okay. Okay, we're multiplying them. -4 times x squared is -4x squared. And we need to find two numbers that multiply to make the top. I'll put a little multiplication sign here. And add to make the bottom. So if we ask ourselves, okay, what multiplies to make -4 and adds up to make +3, hopefully you would eventually realize that you get that with 4 and -1. Okay, but we do have x's involved, so these are going to be x terms. 4 and -1 do add up to 3, and they do multiply to -4, so we're good to go. We'll go ahead and put those in these empty boxes. All right. So now the answer will come from what goes on the outside. This is like backwards multiplication from like what we did on Friday. It's like we're literally doing the backwards process. So we ask ourselves, what times what equals x squared? Well, that's got to be x and x. X times what would give us -4x? That would be -4. And then x times what would give us -1x? That's going to be a -1. So I end up with this for my factored form. X minus 4 and x minus 1, and that came from the outsides of my boxes. So I'm just rewriting the original problem, so that's why I kept the equals 0 there. So now it's super easy where we can say, oh, okay, well, x equals 4 and x equals 1, just like how we did in like all of these problems. So x equals 4, and what did we say? 4 and 1. Oh my goodness, I totally just messed up. Hold up, guys. This should be a positive 4x. I would redo this whole video if I literally had time to, but I don't. I knew something seemed suspicious. Okay, this is positive 4, because this is positive, and so my answer here would be a -4. There we go, fixed it. -4 and 1. Alrighty, moving on. The next activity in the book is, oh wait, no, let's do this first. Oh man. So now we're working backwards. I gave you the solutions and you have to come up with the equation. It's like if I gave you these and you had to give me this part. So if my solution is -5, I know that I need a factor of x plus 5. It's just going to be the opposite. my solution's positive 4, I need an x minus 4. And if I have a 0, remember that just means we have an x chilling by itself. Or you could do x minus 0 as well. I don't care. And then equals 0. Okay, because these are the solutions as long as I want to equal 0 as an outcome. The next one, you'll notice that it wants basically the same equation, but this time we want 4th degree. Here, if we multiplied all these out, you'll see that you'll get x times x times x. This is a 3rd degree equation. So in order to make it a 4th degree equation, let's go ahead and just rewrite it real quick. Oh, wow, this is ugly. Okay. We just need to make it so that when we multiply all this out, we end up with some like x to the 4th term. So in order to do that, we got, all we have to do is square one of these. I could say, okay, well, let's just square this factor or this one or this one. It doesn't matter which one we squared. Let's square this one because that's where I have the most space. So now x squared times x, that would give us a 4th degree polynomial. Okay, and that's exactly what we wanted. All right, so now the next activity is with the card sort. Now, if we were in class, I would give you these cards and you guys would match them and it would have been a great activity, but we ain't got time for that because you got a sub. So I'm gonna talk about the solutions to the card sort as if you had it, just to point out how you can match an equation to the graph. So here's one example, the very first one. Here's an equation. This tells us that we have x-intercepts at 5, 4, and this one, if we solved it, set equal to 0 and solve, you would move the 3 over and you would get 3 over 2. That's also 1.5. I'm saying that because it's way easier to find 1.5 on the graph than it is to find 3 over 2. So we got 1.5, 4, and 5. So we needed to find the graph that had those x-intercepts, and sure enough, oh, sorry, I'm just making all kinds of mistakes. This should be a -3. Negative 1.5. Goodness gracious. Okay, so negative 1.5, that actually is this point right over here. It's on the negative side. 4 and 5 are right here, so that's how we know that the graph matches. Okay, here, this one matched, let's see, we have -5 would make this one 0, -4 would make this one 0, and this, if we set it equal to 0 and solved it, I'll try to stop making mistakes, 3 over 2, which is positive 1.5 for real this time. So sure enough, this description matched it, right? We got the -5, -4, and 3 over 2, just like they said. Same idea here. Let's see, here, this is very similar to the first one, but this one gives us, we want a -5, positive 4, and this one would end up giving us a -3 over 2, which is a -1.5. I'm not going to bother solving that again because I think we've solved enough of those. You guys get the point. So we had to find the graph that has those x-intercepts. So let's see, -5, got it. Positive 4, got it. And -1.5, oh, got it. So that's how you know that this graph matches. All right, so yeah, that's pretty much it. I think you guys get the point. I'm going to end this video now and proceed to drive home 2.5 hours. So have a lovely rest of your day, and I will see you all tomorrow.